looking at how we inspect electrical panels. One of the first things that we want to do when we get to the panel, this house is in pretty poor condition, so a lot of times inspectors may assume that the power is off. One of the things that we want to do, regardless of what the property looks like, is we want to, first off, before we touch any electrical panels, we want to see if it's energized. I use a Fieldpiece SC420 meter. It has a non-contact voltage detector on it. So before we touch the electrical panels, we want to just run our meter around there and make sure that it's not hot, so that we can safely take the cover off. And once we do that, then we'll just take the screws out. We want to be looking at what kind of screws are fastened in here. Make sure they're not sharp pointed, make sure they're correct screws. This particular electrical panel is already missing a lot of screws, but we're going to go ahead and take the cover off now. Once we get the cover off, the next thing that we want to do is find out if there's power on the actual conductors coming into the service panel. So again, I'm going to get my non-contact voltage meter out here, and I'm going to check right up here, and we can see that it's showing us that the power is on. So we got to understand that the electricity is hot and it could be dangerous, and we need to be safe and be cautious of what we're doing. One of the first things that we're going to be looking at is clearances to electrical panels. You're supposed to have approximately 18 inches on each side and 3 feet in front. We can see here that this panel is restricted, does not have clear access for proper servicing because of the enclosure that it's around. That's going to be a problem. We're going to write that up first off. The next thing we want to do is we want to look at all the circuit breakers. Make sure there's only one wire on each breaker. Make sure that they're black wires. Those are the hot conductors. If there's any white wires on the breakers, they need to be identified as black. We want to look for any cut conductors. We want to make sure that the breakers are compatible with the electrical panel. We're not going to turn the electricity on at the main breaker in this particular case because of some other conditions here at the property. And that's, we want to identify the wiring type, whether it's solid core aluminum, if it's stranded aluminum, solid copper. We want to be checking for the wire sizing on some of the breakers. This is a 60 amp breaker. Looks like a number 6 wire that's probably going to the stove. The 20 amp breakers should be a number 12. 15 amp breakers are usually a number 14 wire. We want to make sure that at the main disconnect that our neutral conductor and our grounding conductor is connected. Any other place they're not supposed to be connected, but at the main service panel we want to make sure that they are connected. That is the proper place to ground them. Hello, here we're at the secondary service panel on the same property that we looked at a little earlier. We're going to be identifying some issues here. First off, this is a secondary panel. It's fed from a circuit breaker in the main distribution panel that we looked at earlier. One of the main problems that we find here is there's no disconnect for this panel. The other panel is not within sight, and it's at least 30 to 50 feet away from here. One of the major problems here is this must have a service disconnect at the panel where these 2 feeders come in. We're also going to identify that the grounding bar and the neutral bars, they are separated, which is the way that it's supposed to be. The grounding bar is bonded to the electrical panel, which is the way that it is supposed to be. Some of the other, those are a couple of good things, and it's sometimes a good idea to mention that when your customers are with you during the inspection. One of the problems that we see here is that we have some current carrying conductors that are not identified with a black tape or black stripes on them. These are 220 volt circuits, and they should be identified as black, even though they're on white wires. We do have one here. that's identified. We have a wire splice inside the panel. That's technically okay. There's no issues with that. Over here on our grounding bar, we have double taps on our grounding bus bar, which is approved by the panel manufacturer. However, part of that approval requires that the wire sizing is the same. You can't have a 12 and a 14 wire on the same terminal because there's different variations of the thicknesses. We have a couple problems here where we see that there's at least 3 terminals here that have 2 different wire sizes on those. Over here on our neutral bar, we have double taps on the neutral terminals. Those should all be on a single terminal. Looking at the electrical system again, we have an opportunity to see some of the conductors that were routed to the kitchen and appliance areas. Electrical conductors are required to be protected. They're required to have bushings. They're required to have certain things in place so they don't get damaged. One of the things that we see right here on the bottom of this, where these feeders come out of the wall and were run through the cabinets, is all of these conductors are now exposed. This is a very dangerous arc fault condition. It could cause a fire, and all of this wiring will need to be replaced from here all the way back to at least a junction box or panel location in order to make this safe.